Hi everyone, welcome back. Brand new topic, APs and GPs, arithmetic progressions, geometric progressions. These are all about adding and subtracting. These are all about multiplication. So the geometry comes from the shapes and how often with shapes and areas and volume we're going to multiply. So they refer to it as a geometric progression because we're multiplying. So if you have a look back at the question, we're starting with really easy ones that are quite obvious. It's pretty obvious that is to go from 10 to 12 you add 2. To go from 12 to 14 you add 2. To go from 14 to 16 you add 2. So if they say write it as a recursive rule, here's how you write it as a recursive rule. By the way, this is term 1 and then we call that term 2, term 3. And for those who use class-code calculators, the Japanese people who wrote the program for it don't use T for terms, they use A for terms, which is interesting. Actually, when I was a child at school, we used to use U. I don't know why we use U, but sometimes we use U. Let's have a look what it is. To get this second term, you get the first term. And what did we do to the first term of 10 to get the 12? You can probably notice we added 2. So how did I go from 10 to 12? To get the second term, I had the first term and I added 2. How do I get the third term? I get the second term, which is 12, and I added 2, and I got 14. So that's how we look at a recursive rule. It's saying, what would you have to do if you kept on going and going and going? What would you do each step of the way, like almost like going around in circles to get the next number? So of course I can go to the fourth term, I'd get the third term, and I'd add 2 to it. So when we write that as a recursive rule, we call it, instead of saying 1, 2, 3 or 4, so if I looked at this one here and I said that's n, how do I get the next number? If that was 1, that was 2. If that was 2, that was 3. If that was 3, that was 4. So this is called n plus 1. And that's how we write a recursive rule for an arithmetic progression, because we're adding lots of 2 each time. It's called an arithmetic progression. But what you have to always do is state what the first term is. The first term on this question is 10. Because if I had one similar to that, like 6, 8, 10, 12, it's the same rule that each time to get the next term, you get the previous term and you add 2, but this one starts at 6. Now, I don't know what it is, but when you're marking assessments over and over and over again, doesn't matter where students come from, they forget to write the first term. I feel like stopping here and just going, don't forget to write the first term, almost sing-song. Don't forget to write the first term. Half of you watching will forget to write the first term. Try to make it not you. Or maybe you'll be so nagged about it that you watch your class, you go back to your class and there's 20 people in your class and they do a test, and when they get the results back you'll watch, you'll have a look and a whole lot of students will forget to write the first term. My students handed back talking about it in the assessment yesterday, day before, and students are going, yay, I wrote it. And others are going, no, I didn't write it, which is rather annoying. Let's have a look at what happened here. To go from 3 to 6, you add 3, but that's adding 6. So this is not about adding this time, it's about multiplying. Now if you look at it, it's pretty easy to say, I doubled, and I kept on doubling in this question. So let's have a look at what happens. So again, the recursive rule, we're talking about what is the recursive rule. Common sense question, you can look at it and go, I doubled each time. So to get the second term, I started with the first term, and what did I do to get the second term? I times it by 2. I go through this process again. Some of you don't need it, but just hang in for a second. The third term, you get the second term, and I also multiply it by 2. So you can look at this and you can see I doubled, and then I doubled, and I doubled. Of course, that's the first term. That's the second term, third term, and fourth term. And by the way, a lot of times we call the first term A, which is probably why the Japanese start calling it A for everything, and they'll go A2, A1, A3, and A2. So let's have a look at what's happening to the rule. If I called that one there an N, this is 1 bigger than that, so this is a position. This little number down here in the bottom, see first position, so first position's a 3, second position's a 6, third position's a 12, fourth position's a 20, any position, anywhere, any time's an n, and the one after it will be n plus 1. Now I know that a lot of you will have this question in your head. So there I have it written as a recursive, but what must I always write? Must write where it started. Don't forget to write where it started. It started at 3, so the first term is 3. Now here's what always does people's heads in. They go, well, what if I decide to write that one as an n? So if I wrote that one as n, let's look back to here. If I wrote that as n, it's in the second position. Over here it was the one before it, which was the first position, times by 2. This one here, third position. That one was in the second position, and then you times it by 2. Excuse me, not looking enough. So if I write that as n, this is the one below it. So that was 1 less than that. That was 1 less than that. It's totally acceptable which way you choose to write it. The whole world accepts that people write it either way. You might get a teacher somewhere who says, I want you to write it this way, but you can have a look at it. So again, that's the same recursive as that recursive. Each time we're multiplying, so it's called a geometric progression. Don't forget to write the first term is 3. I want to keep saying it. Don't forget to write the first term is 3. Don't forget to write the first term is 3. Don't forget to write the first term. So you've got to get that first term in all the time. And that's called a recursive rule, and called recursive because it keeps building on itself all the time and keeps going around the circle. Doesn't matter which way you write it, but that's the basic ideas. Now, by the way, if you wanted to write that as 2tn minus 1, that's okay as well. So you could write this as 2tn. Hopefully you're enjoying it. If you're finding it helpful, please spread the word, let other people know. Thanks. And if you want to hit the like and subscribe, you can find out when I'm doing more videos. There's so many coming. Thank you so much.